All right, we're taking a look at this example, so let's read it quick. It says a parachutist relies on air resistance, mainly on her parachute, to decrease the downward velocity. She and her parachute have a mass of 55 kilograms, and at this particular moment, air resistance exerts a total upward force of 620 newtons on her and her parachute. What is the weight of the parachutist? Is what they want to know in part A. Well, weight, okay, so let's think about our free body diagram we're drawing here. So gravity is pulling our parachutist and her parachute down, and air resistance is trying to slow her and her parachute down. So her weight is this force of gravity. And so we had 55 times 9.8. So 55 times 9.8 gives me 539 newtons. Okay, sounds great. Part B wants to know, Part B wants to know, draw a free body diagram for the parachutist. Okay, use the diagram to calculate the net force on the parachute. Is there a net force upward or downward? Okay. So here I have my free body diagram. Now I look at these two forces, 620 up, 539 down. So overall, there's more force up. So that means I have a net force up. But how do I find that net force? So when I think about generating these equations, this value over here is the net force. So there's two ways I can find the net force. If I know the mass and the acceleration, I can just multiply those together and it will tell me what the net force is. The second way is I can add up all the forces to find the net force. So that's the way we're going to do it here. So I have 620 minus 539 equals MA. And so this side right here comes out to be a positive 81 newtons. So this is my net force. So there's a positive net force of 81 newtons up on my parachutist. And C wants to know what is the acceleration, magnitude, and direction of our parachutist. So now I just need to finish solving this. So I have a 55 kilogram mass being accelerated by 81 newtons. So my acceleration comes out to be a positive 1.47 meters per second squared. And since they really noted that magnitude and direction, this positive means upward. So I would change this to acceleration as 1.47 meters per second squared upward as our acceleration.